Hello everyone. Today's topic is Hamming code. So what is this Hamming code? This is an algorithm or a technique which is used to detect the errors and correct the errors. And the main important note is this Hamming code is used to detect or correct the 1 bit errors in a k number of bits of data. So error correction. So previously we discussed what is error detection in the last video. So what is error correction? While transmitting the data, so the sender sends the data and the receiver receives the data. So while sending the data, if it is a noiseless channel, then there is no problem to the receiver and it is correctly received by the receiver. But in some cases, due to the noisy data, means noisy transmission or noisy channel, once detected the errors must be corrected. So for correcting the error, we are using two different techniques. One is retransmission and the other one is forward error correction. So the retransmission is also called as backward error correction, that is BEC. So BEC is the backward error correction, also called as retransmission technique. So that retransmission technique is used to correct the data. So where this one is used? So this is the simplest technique which is used to correct the data. When it will be used mean when sender sends the data and receiver is not getting that data due to the loss of data in the middle. Then in that case what will happen? The sender is sender is waiting for the acknowledgement and receiver is waiting for the data. So if the timer times out, then immediately the sender will send a new data, mean the same copy of data to the receiver. Otherwise retransmission concept is happen by using the acknowledgement concept. So acknowledgement and n acknowledgement, so not acknowledged means negative acknowledgement. So negative acknowledgement in the sense it is used when the data is lost, mean not receiving by the receiver, or in the other case that is called as if any errors are detected. So if any errors are detected at the receiver side, simply the receiver sends the negative acknowledgement to the sender. So negative acknowledgement is nothing but it is requesting to retransmit the same data again. So if it sends the same data again, then by using that we will avoid the errors what in the previous cases existed. So this is one of the technique that is called as backward error correction. So the backward error correction also called as retransmission. So retransmission of the same data will be possible by using the backward error correction. Simply we called it as automatic repeat request. So automatic repeat request means ARQ technique. So ARQ is used. So at sender side sends the data to the receiver and waiting for the acknowledgement. So for example at receiver side the data may lost, or sometimes the defeated, means by using some detection algorithms the receiver will detect some error is occurred in the middle of the channel. Then simply it will send the ARQ, it will apply the ARQ, that is called as automatic repeat request. So by using that automatic repeat request, the sender will receive the acknowledgement from the receiver and it starts retransmit the same data. So by retransmitting we will avoid some errors. So that is one of the technique, and the second one is forward error correction. So in retransmission what the thing is happened mean at receiver side only detecting the error but not correct it. So it is requesting to retransmit again. So the sender again retransmit the data and the correct data is received by the receiver. But in the forward error correction what will happen mean the receiving device can correct the errors itself. So here the receiver by using detection algorithms it will detect the errors. So after detecting the errors the receiving system itself will correct the data. So by using the Hamming code algorithm, so the error detection and error correction is possible. So what is this Hamming code? We will see. So Hamming code is a technique in data link layer which is developed by R.W. Hamming. So R.W. Hamming is the scientist name who invented this Hamming code. So why this Hamming code is introduced mean, Hamming code is used for error detection purpose and correction purpose. So in Hamming code, it is a set of error correction codes that can be used to detect and correct the errors that can occur when the data is transmitted from sender to the receiver. So when sender sends a data, if any error is occurred, that error is corrected by using the error correction codes. So it is very easy to implement. Here we have different type of data bits and redundant bits and parity bits are used. So data bit. So what is data bit mean? The data that the sender want to transmit. Mean what is the original copy of data that sender wants to transmit, that is called as data bits. Simply called original data. Original data. So in data link layer we have the functionality called encoding and decoding. So while transmitting the data there may be a chance of thefting of the data. So to avoid that we just encode the data. By for encoding the data we need to add some extra bits. So that extra bits is nothing but redundant bits. Redundant bits are extra binary bits that are generated and added to the information. So we have the original data is there. For that original data we need to add some extra redundant bits. Extra bits called redundant bits. Carrying bits of data transfer to ensure that no bits were lost during the data transmission. So by adding these redundant bits to the original data while transferring the data to ensure that no bits were lost during the data transmission. Data transmission lo Hamming code. So Hamming code, the number of redundant bits can be calculated. So in the previous case we already discussed data bits. So data bits means original data that the sender wants to transmit. Redundant bits mean at the sender side by using the encoding techniques we are adding some redundant bits. So how many number of redundant bits are added? So how many number of redundant bits are added mean, by using the number of redundant bits can be calculated using the concept of Hamming distance. Hamming distance formula. So what is this Hamming distance formula mean? 2 to the power of r greater than or equal to m plus r plus 1. So this is Hamming distance formula which is used to find the value of redundant bits r. So here r is nothing but redundant bits, m is nothing but number of bits in the original data. So by using this formula we will find how many number of redundant bits are added to the original data. So how we will find mean, we will place or we will put the values of r starting from 0, 1, 2, so on. So first we need to substitute the value of r is equal to 0. So 2 to the power of 0, 2 to the power of 0 means 1, and 1 is greater than or equal to m plus r plus 1. For example, in given data the value is, the number of bits in the given data is 5. So 5. So how we will calculate mean, 2 to the power of 0 greater than or equal to, in original data number of bits is 5 plus r value means here we are taking 0 value, so 5 plus 0 plus 1. So here at the right side the value is 6 and the left side the value is 1. So here the condition is failed. So if the condition failed, simply we will increment the value of r by 1. So in place of r we will put the value of 1. So 2 to the power of 1 greater than or equal to m is equal to 5. So 5 plus 1 plus 1. So in the right side the value is 7 and at the left side the value is 2. Here also the condition fails. Then again we will increment the value of r by 1 value. So now the r value is 2. R value is 2 and m value is 5. So 2 to the power of 2 greater than or equal to 5 plus 2 plus 1. So 2 to the power of 2 means 4. 4 greater than or equal to 5 plus 2 plus 1. 5 plus 2 plus 1 means 8. So here also the condition fail. That means 2 redundant bits are also not sufficient. Then now increment the value of r by 1 value. So that is 3. R is equal to 3. 2 to the power of 3 greater than or equal to 5 plus 3 plus 1. So 2 to the power of 3 means 8. 8 greater than or equal to 8 means here 9. So 8 greater than or equal to 9. Again the condition fail. That means 3 redundant bits are also not sufficient. Then again we will increment the redundant bit value by 1. So that is 4. Now r value is equal to 4 and m value is 5. 2 to the power of 4 greater than or equal to 5 plus 4 plus 1. Here 16 greater than or equal to 10. Now the condition is satisfied. So when r is equal to 4, the condition is satisfied. That means r is equal to 4 and m is equal to 5. So now we need to append these 4 bits to original data 5. So total Hamming code is now 5 plus 4, that is equal to 9. So in this way we will find how many number of redundant bits added to the particular original data. Next, coming to the parity bits. Parity bits. It is a bit appended to the data of binary bits to ensure that the total number of ones is either even or odd. There are two types of parity bits are there. One is even parity, another one is odd parity. So if in case of even parity, the total number of ones in a given set of bit is already even, then we place the parity bits value as 0. For example, consider here, so even parity of 1 0 1 1. So 1 0 1 1, total number of ones are 1 2 3. 3 means it is not an even parity. Then in place of this we will place the parity bit value as 1. So if parity bit value is 1, then total number of ones is now 4, that is even. Then it leads to even parity. So like this we will calculate the even parity and odd parity. So if we consider the second case, what is the second case? 1 0 0 1. So 1 0 0 1. So total number of ones in this data bit is 2. So 2 means it is already even. So that's why in place of parity bit we will put the value as 0. So like this we will calculate the even parity values and odd parity value. So the reverse of even parity is nothing but odd parity. So if the total number of ones in a given set of bits is already odd, then place the parity bits value as 0. Otherwise place 1 value. So number of redundant bits. So here we calculated the redundant bit values by using this formula. So the having given a simple table for this one, how we will calculate. For example, the total number of data bits in the original message M is considered as K. Number of redundant bits is R. Then total number of bits in the code word is K plus R. So for example, the message consists of only one bit, then it requires two number of redundant bits to satisfy the condition. So we will check the condition now. So is it satisfied or not? So here m value is 1. Now we will find the redundant values for m is equal to 1. So here m is equal to 1. We have the formula is there. What is the formula? 2 to the power of r greater than or equal to m plus r plus 1. So now we will check. First m is equal to 1 and place r is equal to 0. So 2 to the power of 0 greater than or equal to 1 plus 0 plus 1. So 1 plus 0 plus 1. So 2 to the power of 0 means 1 greater than or equal to 2. So it seems the condition is fail. If the condition fail, what we will do? We just increment the value of r value. So in place of 0 we will place now 1. 2 to the power of 1 greater than or equal to 1 plus 1 plus 1. 2 to the power of 1 mean it is 2 is greater than or equal to 3. 2 to the power of 1 greater than or equal to 1 plus 1 plus 1. So 2 to the power of 1 mean 2 greater than or equal to 3. So here also condition fails and we need to increment the value of r by 1. So that is r is equal to 2 now. So r is equal to 2. 2 to the power of 2 greater than or equal to 1 plus 2 plus 1. That means 4 greater than or equals to 4. So condition is satisfied here. That means if number of data bits in message original message is 1, then we need to append 2 random bits. So if it is 1, then we will add 2 redundant bits. So totally the code is k plus r, 1 plus 2, that is 3. If the message consists of 2 bits, then we need to add 3 redundant bits. So you people please check, if number of bits is equal to 2, then how many number of redundant bits need to append? By using the condition 2 to the power of r greater than or equal to m plus r plus 1, we will calculate the redundant values here. Once we find the redundant values, the total code word is k plus r. So if it is 3, then 3 redundant bits are used. 4, then 3 redundant bits are used. If number of bits in data is 5, then number of redundant bits is 4. In the previous example, we discussed this one also. Number of bits in the original message is 5, then the number of redundant bits are appended is 4. So if it is 6 bits, then again 4 redundant bits are appended. 7, then also 4 redundant bits are appended. So like this we will calculate how many number of redundant bits added to the original data. Next. So if number of data bits is 7, this is one of the example. Then the position of redundant bits. Okay. In the previous case we discussed how many number of redundant bits are there. Now the case is where the redundant bits are added. So where we have 5 bits of data is there and 4 redundant bits are need to append to this data. Okay. Where we add this one, either LSB side or MSB side or in the middle or in the first position or in the second position, where we place this redundant bits. So where the redundant bits are placed mean by using the 2 to the power of n concept. So the redundant bits are placed in the positions of 2 to the power of n. If you have 4 number of redundant bits are there, 4 redundant bits, that means if the number of data bits in original message is 7, then it requires 4 number of redundant bits. From the table if you observe, so 7 number of bits are there, then we need to append 4 number of redundant bits. So where we place this redundant bit mean 2 to the power of n, where n is equal to 0, 1, 2, 3. 4 possibilities. So 2 to the power of 0 means 1, and 2 to the power of 1 means 2. 2 to the power of 2 means 4, and 2 to the power of 3 means 8. So in the positions of 1, 2, 4 and 8, we will place the redundant values. So redundant bits is considered as R1, R2, R4, R8. So where we place it this one? Actually we have 7 data is there and plus 4 redundant bits are there. So total Hamming code is 11. So see here 11 places are there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in that 11 positions we will place in the first position first random redundant bit, that is R1, in the second position R2 value, in the fourth position, because the positions are 1, 2, 4, 8. So first we place the redundant bits in that particular position, and the remaining all the positions, all other positions are filled with data D. Understand? Next. So this is the algorithm for Hamming code. So we need to follow some step-by-step procedure. So what is the algorithm mean? First one is, in the first step, write the bit positions starting from 1. So in the previous case same thing we done. So first we need to write down the positions starting from 1, 1, 2, 3, 4 like that. Second, all the bit positions that are power of 2 marked as redundant bits. So in the second step we will take the power of 2 and calculate number of redundant positions and place the redundant positions with the positions with redundant bits. So in the second one, all the bit positions that are a power of 2 marked as redundant bits. So that is 1, 2, 4, 8, 16, 32, 64, 128. So like that. So in that bit positions we need to append the redundant bit. In the third step, all the remaining other positions are marked as data bits. So once we place the redundant bits, remaining bits are there. So that remaining empty bits are filled with data value. In the fourth step, each data bit is included in a unique set of redundant bits as determined by its positions in the binary form. So here the original data is already known, but the redundant bits are not known to us, right? So we are assuming some redundant bits, that is R1, R2, R4, R8. So here redundant bits are R1, R2, R4 and R8. So we know the values of D because that is already the sender wants to transmit. So D values are already known. Now what is our task? We need to find the R1 value, R2 value, R4 value and R8 value. So how we will find this R1, R2, R4 and R8 is, in step 4 we need to find the values of redundant bits. So how we will find the redundant bits mean? By using the even parity concept. So parity bit 1 covers all the bit positions of binary representation 1 in least significant positions 1, 3, 5, 7 etc. So how we will calculate mean? By using this table. So we need to determine the parity bit positions for redundant bits. So to calculate the redundant bit value, we need to consider the positions, parity bit positions of a particular data. So here we write the positions. So how many bits are there? 7 bits. 0, 1, 2, 3, 4, 5, 6, 7. So for example 7 bits are there in the data, means data along with redundant bits is 7. Now we need to write down in a binary format. For 0, 0, 0, 0, 1, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and finally 1, 1, 1. Now we need to consider the ones in that particular position. So for R1, to find the position for redundant bits, we need to consider all the ones, eliminate zeros and only consider where 1 is there. So 1, 1, 2, 3, 4. Now take the positions of that R1. So what are the positions of R1 now? 1 at position 1 and 3 and 5 and 7. So these 1, 3, 5, 7 is used to determine the parity bit positions for redundant bits. So like that for R2. So for R2 we need to take the values 2, 3, 6, 7. So for R2, 2, 3, 6 and 7. So these positions values are used to find the even parity. And for R4 we need to find 4, 5, 6, 7 positions. 4, 5, 6, 7. These are used to find the R4 value. And 2, 3, 6, 7 is used for R2. And 1, 3, 5, 7 is used for finding the R1 values. So this is in the step 4. So in general, each parity bit covers the bitwise and the bit position is non-zero. So by applying this technique, we will find the even parity values. So in the final, check the even parity. So we need to find the even parity for each and every values. So consider the example and we will explain it. So this is the concept of Hamming code. The example for Hamming code is explained in the next video. Please follow my channel. For that, for example of this Hamming code, you need to subscribe my channel and follow the further videos. Thank you.